Unit 6.2 is to solve quadratic functions by graphing. Okay? If you look at the notes, there are 1, 2, 3, 4 names for solutions of quadratic functions. So solutions of quadratic functions can be called any of these things depending on what we're looking at. They can be called roots. They can be called zeros. It is where the graph crosses the x-axis, and it's when y equals 0. Okay, so they're the 4 times. Solutions root zeros is where the parabola crosses the x-axis and when y equals 0. Okay, now there's 3 possibilities. I already drew them on your notes for you. The first possibility is that it never crosses the x-axis. If it never crosses the x-axis, that's no real solution, which means we have imaginary roots. Okay, before, in Algebra 1, we just said no real solutions. Now we're going to know that there's going to be imaginary. It's going to be a complex number, the answers. Okay, we could have where the vertex is just sitting right on the axis. So it doesn't really cross the x-axis, but we call it that, and that's going to be a 1 solution. The only other possibility with parabolas is the one that we're kind of the most familiar with, and that's where it crosses the x-axis twice. Wow, that's a terrible arrow. So wherever it crosses twice, that's 2 solutions. Okay, so they're the possibilities. So really we're going to do the exact same thing that we were doing in the unit section 1. We're going to graph it, but now we have to add a couple things to it. We have to figure out where it's crossing the x-axis, and that's going to be our solutions. Okay, so let's do a couple of examples. Again, you don't have to do them all with me. You can do 1 or 2. It's up to you. X squared plus 6x plus 8 equals 0. It could also equal f of x. It means the same thing. Same thing as before. Negative b over 2a. I don't know why it's flashing on and off like that. So that's negative 6 over 2 times 1. And so that gives us negative 3 is our axis of symmetry. We're going to put that in the middle of our table, just like before. So negative 3 count up and down. And then I get my graphing calculator and I fill in the y values. I'm going to graph it and then answer my questions. So negative 3, negative 1, negative 2, 0, negative 4, 0, negative 1, 3, 1, 2, 3, and negative 5, 3, and then I'm going to, don't just give me dots. Connect the dots, please. There's my parabola. And then we have to answer the questions. Vertex is going to be negative 3, negative 1. It's that center point. Axis of symmetry. That's what we figure out at the very beginning. That's our starting point. That means, what's this line right here through the middle? And that's where it's x equals negative 3. Make sure you put x equals. Y-intercept. Now this time my y-intercept is not on the table that I wrote down on my sheet. So I'm going to go back to my graphing calculator. I'm going to go where x, I'm going to look at my table. I'm going to go x equals 0 and find it. And it's 0, 8. Don't just rely on your graph because our graphs are pretty crude. They're not very nice and neat. Now the solutions. Remember, the solutions, the zeros, the roots, are where the parabola is or are where the parabola crosses the x-axis. And if it's crossing the x-axis, that's where y equals 0. So this time we're going to look in the y column and find the zeros. Now the way we denote this is with a bracket. Negative 4 is one of the solutions, and negative 2. This is not an ordered pair. This is a group of numbers, okay? Negative 4 and negative 2 are the solutions. This is where it crosses the x-axis, okay? Okay, let's do number 2 is negative x squared plus 8x minus 16 equals 0. Again, to find the x-axis to start the problem is negative b over 2a. Be careful of your negatives here. So this gives you positive 4. I put that in the middle of my table. So that's, oops, is it negative 4 or positive 4? Oh, it's positive 4. So positive 4, count up, count down, pick up my calculator, find my table, put in my values. And now I graph it. And again, you can look at the graph on your graphing calculator so you have an idea what it's going to look like. 4, 0, 1, 2, 3, 4. And then negative 1, negative 1. And negative 4, 1, 1, 2, 3, 4. And you can see how quickly these graphs come out because they're symmetrical and we're following the axis of symmetry. Okay? We answer our questions. The vertex, we already know this because we figured it out from the axis of symmetry is 4, 0. The axis of symmetry is always the x value of the vertex, which is what we figured out in the beginning. So it's x equals 4. You got to put x equals because it's actually it's referring to the line on which we're going to fold. And it's going to be the same on both sides. The y-intercept, this one especially, I cannot see on my graph and I can't see on my table. So I go to my table and my graphing calculator and I keep scrolling till I get till x is 0. And that's going to be 0, negative 16. That's pretty far down. So you have to use, if you don't have a graphing calculator, you have to plug in 0. And some of you are going to see where it is. You can see it in the graph and see what your answer is. Okay? Now this one has one solution. Again, remember the solution, the 0, the root, is where where y equals 0. So in this case, we're looking where is y equal to 0. And in this case, it happens to be the vertex. So it's the answer, whoops. The solution, again, we use our squiggle lines, is just 4. It's not an ordered pair. The solution is 4. Now, on the notes, you will also see information on how to find the solutions if it's not a whole number. If it's an integer, how do we find it using our graphing calculator? So I'm going to go through those steps with you in class with a graphing calculator so that if you were trying to graph it and it's not an integer answer, we wouldn't see it on the table. We'd have to find it on the graph. So we'll do that in class.